knapsack. So what does it mean? So what do you mean by 0, 1? So you will have an element, either you can consider it or you don't consider it to get the target. So which is what? 0, 1 knapsack. So it's a bounded knapsack. So bounded means you can consider element only once. So you don't consider elements more than once. So it means, for example, I'm at element 1. Either you take it or you don't take it, you will move on to element 2. So this is what it is. So this is called bounded knapsack. So there is also a concept called as unbounded knapsack. So in unbounded knapsack, so it is something different. So you have element 1, either you consider or you don't consider. You can repeat the same element any number of times. So you can repeat the same element any number of times. Based on the condition, we will just eliminate the element. But in a bounded knapsack, both are same, bounded, unbounded. The only difference is in unbounded knapsack, you can repeat the element any number of times. In a bounded knapsack, you repeat the element only once. So either you consider or you don't consider. So let's discuss about the problems on bounded knapsack, then we will move on to unbounded knapsack. Okay, so yeah, so let's move on. So this is a problem statement. So what he's trying to say is you will be given an array. For example, the array is, let's say the array is, can you send this? So let's say array is 1, 5, 11, 5. This is the array. So we need to find out equal partition equal subset sum. So what do you mean by subset? What do you mean by subset? What do you mean by subset, buddy? For example, if there is one, two, three, so what are the subsets you have? That is subarray, right? So in a subarray, what you have? So can I say 1, 3 is a subset? It's not continuous, right? It's not continuous. Uh, it means it is continuous, but you can skip the indexes in the middle, right? So you can call it as a subsequence also same. Okay, so let's see here. You have one here, so one, two, and one, two, three, and you have two, and two, three, and three. So these are the subsets you have, right? So similarly, assume that the total sum is 6. So the total sum is 6. Assume that. So what he's trying to say is you will be given an array something like this. You will be given an array something like this. Can you get a equal partition subset sum? What do you mean by equal partition subset sum? So you divide this total. Let's consider. Can you equal partition subset sum means, for example, the total sum of this how much it is 22, right? So the total sum of this array is 22. Can you divide this subset into two parts? This array into two subsets, subset 1 and subset 2. Can you divide this array into two subsets where the sum of both the subsets are equal? So that's what the problem statement says. So it means, for example, if you closely see, total is 12, right? The total sum is 12, so that you can divide if it is if you are able to divide this into two equal subsets. It means 1, 5, 5 and 11. So if you closely see, the sum of the first subset is 11, sum of the second subset also 11, the total is going to be 22. So are you understanding what I'm trying to say? Is that clear, Ajay, Akash? So simple, right? So you wanted to find out partition equal subset sum. So you will be just given an array. So the total sum can be divided into two subsets or not. So that's it. So that's the problem statement saying. So let me take a simple input so that things will be cleaner. We can go with the same input. Okay, 1, 5, 11, 5. Okay, so 1, 5, 11, 5. Okay, so we have indexes 0, 1, 2, 3. So first thing is if you closely observe, if you want to divide the total subset, the total array into two subsets, whatever elements included in first subset definitely not included in second subset. Is that clear? If you want to divide this array into two subsets, whatever elements included in first subset definitely not included in second subset. Correct? Correct. So indirectly, if I get a subset sum of total sum by two, then subset other one will obviously be sum by two, right? If I get one subset sum is equal to one subset term is equal to sum by two, then other subset will definitely be sum by two, right? Do you understand this point? For example, I have 1, 5, 11, 5. Okay. Somehow I derived a subset of 1, 5, 5. Okay. The sum of this subset is what, buddy? The sum of this subset is what? 1, 5, 5. 11, right? The sum of this subset is 11. It means if you find one subset sum which is equal to sum by 2, total sum is what? Total sum is here 22. If you are able to find one subset sum which is equal to 11 and it means sum by 2, then other one obviously be sum by 2, right? Because these elements won't be included in those subset, right? Is that clear, Ajay? So this is only the tricky point in this use case. Okay, so what we should do is, so we have total sum. If you closely see, sum equal to 22. So what is our target now? What is our target now? So our target is we need to figure out a subset. We need to figure out a subset uh, whose whose target is equal to sum by 2. So it means sum by 2, so which is equal to 11. Okay, so we need to figure out a target whose sum is equal to 11. Now, the most confusing part is generally if you remember, whenever you design a subset problem, so how do you did it? So let's do that. When do you know that you reached a subset? When do you know that you are deriving a subset? Did you practice that problem, buddy? Subset problem. Okay, let's move on. So what is a one thing we understood is one thing we understood is we have a total sum as 22. We have total sum as 22, and if I figure out a one of the subset sum is equal to target by sum by 2, so one of the subset value as 11, so the other subset value definitely be 11, so that I can return true. So the only ask is, can you divide this subset can you divide this array into equal partition subsets? If you are able to do it, return true, otherwise return false. So that's a ask. So let's move on. What we can do is, first we will start from, so here we will start from index 0. Okay, so I'm starting from index 0. So I'm starting from index 0 and the target I have is 11. Okay, so I need to find out a subset which the total sum is equal, the total subset sum is equal to 11. So the target is 11. So first thing is I can include or exclude. So if I include, it means if I include the current I0, so the I0 value, index 0 value, so index 0 value is 1. If I include, either I include or exclude, I will reach to index 1 for sure. Okay, but if I include, there is a change in the target, na? Yes or no, buddy? There will be a change in the target, right? Because I included the current index, so that the next target becomes 10, right? Yes or no? Is that clear, Ajay, Kalyan? So now again here also either I can include or exclude. Okay, I can include or I exclude. Either of the cases I will reach to index 2. Either of the cases I reach to index 2. But if I include, then I need to subtract index 1 value, which is 5. So definitely this is the file. So either I can include or exclude. So if I include, definitely I need to subtract index 1 value. So index 1 value definitely 5. So subtracting 10 from 5, so which is going to be 5. If I exclude, there will be a same value will be carry forward. Here is the 10, so same value will be carry forward. Now I'm at index 2. So here also I can include or exclude. Same position applied here. So either of the cases you will reach index 3. I'm directly writing here. So you see, if you include index 2, okay, if I include index 2, now my target becomes minus 6. Yes or no? Because the index 2 value is 11. So index 2 value is 11, but expected target is 5. If I include index 2, the target becomes minus 6. So when the target is reaching negative case, right, you understand that this is the base case. So you definitely not derive so that you don't need to explore further paths so that I can ignore this. And what I'll do, and I include, I see that this is the problem. Let me erase this. So when I include, I see that this is the problem. Then what I'll do, I will try to exclude. So if I exclude, I will reach I3. Okay, so I'll reach I3. So if I reach I3, then I can include I3 or I can exclude I3. Okay, so but here the expected target is what? So 5 only. If you exclude whatever target you have, same will be carry forwarded to the next index. Now if I include I3, see I3 value is 5, correct? I3 value is 5. Nice. So our I3 is value is 5. So definitely if you include, either you include or exclude, you will reach to the I4 for sure. You will reach to the I4. But if you include, if you closely see, if you include, the target value is 5, right? So the I3 value is 5, expected target also 5, then you will reach to 0. You will reach to 0. More importantly, what you need to understand is when do you derive a subset? So whenever you reach the index is equivalent to nums dot length, it means you are able to form a subset in either of the direction. If you closely see, I0 I included, I1 I included, then yeah, so I0 I included, I1 I included, then I2 I excluded, I3 I included. So it means 0, 1, 3 is included. So 0, 1, 3 were being included. So with 0, 1, 3, so you have 1, 5, 5. So the target is 11. So it means you found a subset with the target equal to 11. So with the target equal 11, so definitely you can return true. So once one direction returns true now, so this will return true, this will return true, and this will return true. So if one direction returns true now, you don't need to explore other possibilities, right? Do you need to explore other possibilities, buddy? There is no point of exploring other possibilities, right? So because if you find one subset, so I'm not writing that recursion tree, but you can try for negative test case. So there you will explore all the possibilities. So now one important point is what are the base cases? Tell me, bro, what are the base cases? Okay, so for example, my input is this one. One. Okay, so when the target equals 0, you will return true. Is that the correct? When do you need to check the target is 0? So when do you form a subset? So if you go back to our subset problem, right? How do you form a subset, buddy? For example, you have one, 2, 3, right? One, 2, 3. So if you want to form a subset, so you are at index 0, you have include, exclude, then you will have index 1, include, exclude, index 2, index 2, then again include, exclude, index 3 and index 3. Here also include, exclude, index 3 and index 3. Now if you closely see, I included, so here I'll get 1, again I included, here I'll get 2, It means I included current one value. Closely see here. So initially my subset is empty. So that I0 I included, so subset becomes 1. Right, what I have index 1, so that I included, so the subset becomes 1, 2. Now at I2, so I included I2, so that subset becomes 1, 2, 3. Now when you exclude from I2, so same subset will be carry forward, it is 1, 2. Similarly here, you did include, so from 1 I exclude, so you will get 1 here. Then again I2 I include, so that it becomes 1 comma 3. If you exclude again, it becomes 1. So it means you got a subset. So when did you get a subset? Do you get a subset in the middle or in the end? Do you think these are the subsets? These are the resulted subsets? No, right? So these are the resulted subsets, right? Yes or nobody? Everybody, please. Correct, Ajay? So when do you get a subset? When do you confirm that you got a subset? Correct, right? So here n equal 3, right? So when the index is equal to given length, then you frame a subset. Now, whenever you frame a subset, then you get a 0, then you found a valid result, right? So it means if if your index is equivalent to nums dot length, right? Then what you do, you will return if target equal to 0, you will return true, otherwise you will return false, correct? Yes or nobody? Yes or no? So this is one base case, okay? So this is one base case. What is the other base case? What is the other base case, please? So what is, sorry, when? No, that is what we are doing, right? So we are subtracting the target. Target becomes 0. How does it become 0? That is already covered, right? What is other base case? So when target less than 0, so what should we do? Do we need to explore further? So we simply return false, right? Okay, so I'm not taking the long test case so that we can concentrate on the logic. As you already know recursion, so hope things will be clear. So done, buddy. So we were able to write a recursive logic for this. Then we will think about other alternatives. Okay, so let's move on. So, so one thing for sure. So yeah, what is the state of my recursive method? Can you tell me what my recursive method will take? Okay, so one is index. Then, so what do you mean by sum by value? Target, sir. Yeah, sum by two. No, we don't. We will handle to the same target, right? Whatever target we get, we subtract it and we handle to the, so we don't need to take additional variable, same target. Then what else? Our input array. Correct? Correct, no? So these are only the three variables we require. So let's try that. Private boolean. Uh, so it's a target sum. You will find a problem called target sum. So you can look for that, and it's a target sum problem. But it's a simple twist. So you need a target, and you will have nums. Okay, so for sure this is what. So what we need to do? So we need to see if your index is equal to nums dot length, then you can return. If target is equal to 0, then you can return true. Otherwise, you can return false. Okay, this is one base case. If target is less than 0, you can blindly return false. Otherwise, what is our job? You can return. Uh, so I'm writing in single program. Okay. So let's say uh, so You can take boolean take. So if you want to take it, so what do you do? So on the target sum, you will move on to the next index. As you considering it, so you just need to subtract the current value from the target. Nums of index, comma nums. Is that clear, buddy? Is that clear? So you can say it is considered. So you will consider it. So you just take is good variable. So if you don't take, what do you call don't take? Not take. Huh? Is it correct, buddy? Not take. Consider. So include, not include. So if you don't include, you will move on to the same index, but there is no change in the target. Okay, simply you will just write include or not include. So there will be a great improvement in this if you are able to find out a logic. Okay, so include or not include, right? Okay. So uh, now what is our job? First we need to find out sum. So initial is 0 and we will just take the total sum from the given input. Sum plus equal num, and our target is going to be sum by 2. So, but more importantly, if the sum is odd number, then you cannot divide into equal partitions, right? Yes or no, buddy? If the sum is odd number, you cannot divide into equal partition, na? So definitely you can check that if sum percentile by 2, which is equal to 1, then you can return false. So there is no point in exploring. Otherwise, you can find out a target. So return target sum for the given index starting from 0 and target then nums. Okay, so let's see. So, but you can improvise this with great things. So the problem is if the include is returning true, right? So you can check one way is if include already returned true. If include already returned true, then you can blindly return true here because there is no point in not ex then you can find out whatever value which returns not include. So do not need to explore this. So I can do one thing, the same line can be written this way. If it is include and this is not include. So you can write in single line and you can avoid this. So that way you can simply improvise it. Okay, that's it. Now let's understand, we need to convert this into memoization. So we need to convert this into memoization. Now, do we have any good input? One, two, three. Let me ask ChatGPT. Okay, so we need to convert this into memoization. So when you convert into memoization, right, don't worry about how do you identify, how do you identify what are the problems which are repeating, right? So what are the problems which are repeating? So how do you identify? So throughout your recursion call, right, what are the parameters which are changing? So which are deciding to us to lead to the memoization. But to get into memoization, first we need to understand does the problem is been repeated or not. Let me do one thing. Yeah. So I didn't explain that right. So what is the time complexity here, buddy? What is the time complexity? Yeah, so it's 2 power n, right? In worst case, you will explore all possibilities. Na? For example, there is no target. For example, you have value as 1, 5, 11, 3. So what is the sum now? Which is 9 plus 11, so which is 20. Sum equal 20. and target equal 10, right? Do you find a target 10 here? Do you find target 10 here? Oh, so if you see this, so I'm just directly writing index 0 and target 10. You include, exclude. If you if you include, so it returns index 1. So here target becomes 9 and here 10. So I'm directly writing, so hope you are following me. Okay, let me move this a little aside. Okay, so now if you include index 1, 9 minus 5, it is 4, and if you exclude, it becomes 9. So index 2, 11, so definitely it is negative value, so minus 7. Definitely you will ignore it, and if you exclude, again you will get into index 3 with the same sum, which is 9. So again you will reach index 4, include, exclude. It is 4, right? So it is 4. So if you include 3, so it becomes 1, and if you exclude, it becomes 4. So as you reached it and you are not reaching, as you reach it, you are not reaching, your target is not equal to 0, so you will return false. This is also false. This value becomes false. So let me try this way also. So here the target, if you include index 2, so if you include index 2 for this target, so it becomes minus. So definitely it is returning false. And if you exclude, you will get into index 3, the value is 9. Again, you get to index 4. But if you include or exclude, you will get value as 6, 9. So this will also return false. So that altogether this is false, this is false. So this part is false now. So you will try for other possibilities. I want you to see the duplicate problems. So this is 10. Uh, Now you try to include or exclude. So if you include, you will get 5. If you exclude, you will get 10. Include, exclude, include, exclude. I3, I3. Okay, so if you include I2, definitely it is minus 1. If you exclude, it is 5, I4, I4. So definitely it is 2, 5. So in this case, I2 means 1, then minus 2 and 1, then exclude means 10. So it is 7 and 10. So all are returning false. The only thing is, do you see any duplicate problems here? Uh, we taken very complicated input and none of the. But if you closely see, we have explored all the possibilities so that it is 2 power n. Uh, so if I could have, do you see any duplicates of problems? No. I need to come up with better input so that you will understand. Let me ask ChatGPT. Yeah. Okay, so let me explore that. We can try one so that things will be cleaner. Yeah. 1 1 1 2 2 2 2. one blind thought is whenever you are coming up with memoization, right? So whenever you are coming up with memoization, uh, do you see any duplicate problems here? No. How do you identify the duplicate problem here? Can you tell me? How do you identify the duplicate problem here? Yes, that's the thing, right? So if you say two things are matters. One is index, another one is target. So do you see where the index and the target both are same? I don't think we could find that. Yeah, so in this example we didn't find it. But generally what you do, so let's say 1 1 1 and 2 2 2, 1 1 1 2 2 2. So what is the target? 2 2, okay. So 4 plus 6, which is going to be 10. Do you find 10? It means the subset sum is 5. So can you find subset sum 5? Yes. So we can find target 5, right? So can we find a target here? Target 5 here? We can find, right? So 2 1 1 1 and 2 2 1. So there are total 7 elements. So there are total 7 elements. Okay, so now if you see here, let me do it quickly. You can at least understand. Our target is 5 now. So we need to go with index 0, target 5, and index 1. Or do you understand? Can you explore on this? But you need clarity, right? So 4, 1, 5, 2, 3, 2, 4, and 0, 1, 2, 3. Okay. So 3, 2, 3, 3, 0, 3. Okay. 4, 1, 4, 2. Okay. So let's go further. Let's try till here. Do you find anything like this? If I go exclude uh, 2, 4, yeah, 2, 5. So if you closely see, do you find 2, 4? So if you closely see, repeated, right? Do you see repetition? Yes or nobody? So there is a repetition, right? So so that you don't need to solve this problem again. So you can directly return based on this. Somewhere you will solve it here. So if you explore this one, you could find lot of sub problems. So one thing for sure, how do you come up with the memoization, right? Simple. So this is your recursive tree, right? So in this recursion tree, what are the parameters which are changing? So based on those parameters, you can come up with the memoization. So for this case, I took complicated input. That's why you couldn't get anything. But if you take this, definitely you find one is index, another one is target. With the same index, with the same target, if you already solved it, then you can return the same value so that you don't need to resolve it again and again. So that what is the time complexity now? So now what is the state of my DP array? What is the state of my DP array, buddy? Can you tell me? Means how do you initialize the DP array? Can you tell me? But it only gives the length, right? Input array will have only length. It doesn't have the target, right? So you need a single dimensional array or two dimensional array. But how do you know? How do you know it is? For example, if you take single array, then it will only give the information to indexes, right? But we need information. We need information of. We need information of value also, right? So it's a combination of two, na? It's a combination of two, right? Index and target sum. It's a combination of two, right? Mm. But don't you think with the same index you have multiple sums? See, for same index you have multiple sums, right? How do you handle it? So that's a good question, but yeah, so how do you handle this? So now you understand that for a given index, what are the possible sums? What are the possible sums? 0 to target, right? Yes or no, buddy? For a given index, if you so closely see year 3, year 4, which is less than or equal to target, right? So for a given index, the target sum starting from 0 to target, right? Then how do you represent this? Simple, buddy. That's a two-dimensional array. Okay, so you will go with the Boolean array of two-dimensional array. So where so here the row is n. So n is nothing but length of this array. Value equal target. Sorry. So the row and column size, right? So target plus one. So we need to consider till target, na. So target plus one. So if you closely see, assume that 2 by 3. So what does it represent? So there are two indexes. So 0 and 1 whose target can be 0, 1, 2, 3. Correct, na? Do you understand this? Others, please. So the state of the DP can be defined, right? So Kalyan, did you understand? So okay, so I don't need to explain them. So simple, right? So you will have a Boolean array because here it is Boolean because we just need to return Boolean value, right? So here a row is length of a given input array and column equal target. So target plus one. So which is representing for each index the target can be 0 to target. So that's what we have. For each index the value can be 0 to target. So that's why target plus 1. So if it is already solved, don't solve it. If it is not solved, then solve it. Then what is the time complexity now? What is the time complexity, please? So one is n cross. What is that? Other one? Target, right? So n cross target, right? That's it. So time complexity is n cross target. What is the space complexity? So it is same, right? So n cross t. So one is 2D, other is what could be the stack size, maximum stack size? What could be the stack size, buddy? Why it is n? Depth. So is it not n cross c, n cross t or n plus t or only n? Why it is n plus t? So if you are saying n plus t means you didn't understand the base case. So when are we stopping it? Hmm. So definitely it's not n plus t, right? Definitely it is n, right? So at any point in time, we stop at n. So once this is done, then we will eliminate this, then we'll move on this. So something like this it will go. So at any point in time, the stack size is always linear. Correct? Correct, na Kalyan? So the stack size is linear. Okay, so let me. So what you should do, just go to this. You already know what are the repeated problems. So what is your job now? So just take Boolean array so that you can have a wrapper types. Boolean of dp equal new Boolean of nums dot length and target plus 1. Okay, because index number starting from 0 to n minus 1, right? So target plus 1. So let's do that and pass the dp here, and you will take the same dp, place it here. Here also same dp, here also same dp. And what you do, so before solving the problem, before getting into the problem, check if the current dp with the current index and the current target is not equal to null. It means if it is already solved, just return that. Otherwise, solve it and return it. Okay, so I hope you are able to understand this. Clear, buddy? Clear? Clear, Kalyan? So there is no change, right? I just so now this will definitely submit. Okay. For this, we need to see the tabulation. Let's see tabulation tomorrow, because I'll explain one tabulation so that you can explain for other one. So we will solve one more problem. So that tomorrow if I explain one tabulation, you can explain for other tabulation, because if I am giving homework to you, you are not doing it. So better we will handle it in class. Okay. So the next problem is target sum. So let's look at it. So, but tomorrow don't expect me to explain the same problem again. Please take a look at the problem before attending session so that we can directly get into the tabulation. That is also same pattern. So we need to understand. So this is not as simple as previous one. So we just need to understand the concept behind it so that tabulation becomes dead easy. Okay, now let's solve target sum. So this is also similar kind of problem, but you can able to catch it if I explain the problem statement. You will be given an input, so 1, 1, 1, 1, 1. So let's say 5, and target equal 3, buddy. So you will be given an input. So we need to figure out. So either you can add plus 1, plus or minus symbol to the given input for each index. You need to find out the possible equations where the sum is equivalent to target. Okay, so let's say if you closely see, this is one equation, so I can take 1 plus 1 plus 1 plus minus 1 minus 1, so which minus 1 plus 1, which is going to be 3. I will repeat here. If you closely see, we need to find out all the subsets. So we need to consider all the elements, buddy, for sure. We need to consider all the elements. So we can include either plus or minus. That is our choice. We need to find out all the equation. The equation should include all the elements. Okay, not you cannot say that I will include first three elements. The sum is three. No. So the equation should include all the elements, where the sum of all the elements based on these plus and minus, which is equal to target. If you closely see, I'll take first element as minus 1, remaining all are plus, so that the sum is 3. Then I'll take second element as minus 1, remaining all are plus, 3. Third element as minus 1, remaining all are plus. Fourth element as minus 1, remaining all are plus. Fifth element as minus 1, remaining all are plus. So that you got total equations with the target equal to 3, which is 5, so that we need to return 5. The problem statement is clear. Okay. Now how do you solve it, right? How do you solve it, buddy? So how do you solve it? No, no, no. We always pick elements right here. Are we not picking? So it's here the constraint is on operator, not on the element, right? So we always pick elements for sure. Okay, we always pick elements for sure. So it means I am here. So I am here. Okay, so based on what you need to start. So all are ones, right? So let me make it one. So it is 0, 1, 2, 3, 4. Okay. So first, so it's up to you. How do you want to start it? How do you want to start it? Yeah, how do you, yes, that's correct. So it's an abstract problem only. And how do you do it? Hmm. That I understand. How do you come? Okay, so positive means if I take positive, okay, then mm, mm, mm. Include means minus. You're saying, right? Exclude means so what does it mean? So first thing is never ever don't compare the problems. Okay, so uh, don't think that that's the problem, then we will apply the same logic here. Don't go in that direction here. Yeah, so it's good to get a thought so that at least you will understand, but you will get a thought, that is for sure. Okay, I'll take plus, I'll include, so that one becomes, if you include current one, it becomes 4, then that is going to be invalid result, right? So or if you exclude, it becomes 3 minus 1. So exclude means if you consider as minus 1, then it becomes 2. So in that direction you cannot able to solve this problem. So how do you think about it is, so first thing is you have a element 0, right? You have a element 0. It can be plus 1 or it can be minus 1, correct? Yes or nobody? So it can be plus or it can be minus, correct? So initially when you are at here, forget about target, okay? Forget about target. Target is 3, right? Don't compare as previous thing. Okay, so target is 3. So I'm at index 0. It can be plus 1 or it can be minus 1. If it is plus 1, so initially it is 0. If it is plus 1, my total sum becomes 1. So either it can be plus 1 or minus 1. I will reach to index 2. Okay, nice. I'll do for one direction. Hope you are able to understand that. Remaining direction you can fill it. So it can be minus. So either of the case you will reach to index 1. I think you already get the thought, right? So this is more critical. So if you get a first step done, so here it is initially 0, so now it becomes 1. Here it becomes minus 1 because it is minus, right? Now again you will have plus minus. Okay, so I'll solve for this left tree, then you can try for this one later so that we will get everything. Okay, so I'll go for plus minus. If I go plus, I'll go index 2 again. So if I go, it will sum becomes 2, but here if I go minus, then sum becomes 0, correct? So 1 minus 1 becomes 0, na? Correct, na? So 1 plus 1 becomes 2. Now again same thing, index 3, index 3, sum becomes 3 here, plus minus, right? So here sum becomes 1. Then again index 4 and index 4 plus minus, sum becomes 4. Here sum becomes 2, right? So again same case, index 5, index 5. So if you plus, it becomes 5, but if you minus, it becomes 3, correct? Correct, nobody? So similarly here also plus and minus. So if you plus, you will reach index 5 and index 5. If it is plus, it becomes 3. If it is minus, it becomes 1. So now if you closely see, we have found, I am not driving all the directions. If you closely see, we have found a direction called, let me highlight that. Let's consider the target. So when the index is reaching 5, right? Index is reaching 5 means you are including all the elements for sure. You are including all the elements, but here the inclusion of the value based on the symbols. So that's what you need to understand. Okay, nice. So let's go. So index equal 5, where target equal to 3. So we found already two targets. Let's consider those expressions. So it means what you did. So 1. So if you closely see, you included this 1 plus 1 plus, then then again 1 plus, okay. Then what you did, you found a target in this direction, right? So again, you see minus 1 and plus 1, right? So you found one equation. So this is what we derived, right? So if you closely see, so if you closely see, it is 1 plus, so 1 plus, 1 plus, minus 1, plus 1, minus 1, plus 1. So we derived one equation. And we also get 3 any place. We also get 3 here. If you closely see, all plus 1s and finally 1 minus 1. So this is also one equation. So all plus 1s, finally we got minus 1. So this is also formed one equation. Hope you are able to catch me, right? Correct, na? So somehow, so if you derive all these things, you will get it. So now you tell me what is the base case. What is the base case, buddy? Uh, index equal, index equal, index equal length of the array. Then what you should do? What? So you should, yeah. So total sum equal target. Then what you should do? What you should do, buddy? True or false? Then how do you find out the count? We need count, right? That's what I'm saying, right? So def one, right? So it means you found a count. Otherwise, minus one. What if we return minus one? It should be zero. If you return minus one, gone. Uh, Done. So we are done with base case, man. So we are done with all possibilities also. So then now let's. So it means if you closely see, let me make it little shorter. So let me take it simple input and make it little shorter so that you will understand the code in a better way. So there is only one, and target equal to 2, buddy. Okay, so target is 2 now. So what do you do? So I0, I1, I1, I2, I2, I3, 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 I3. Let's take only three things, three elements. Okay. So let me copy this. Okay. So let's take only three, and we got everything. And okay. So what is our job? Plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. Correct? So let's go this. Let's go this. First, I'll have 1 plus. Let's find out all the equations. Okay, so here it becomes so 1 plus again, let me go this way. Hope you are able to catch me. So it is 1 plus, let me write here, buddy. So 1 plus, again we'll take 1 plus, again if we go minus 1, so which will be 2, and you have 1 plus 1 plus 1 plus, which is 3. So there are two directions here if you closely see. So I took two directions, 1 plus 1 plus minus 1, and one other direction is all pluses. So I took this one, and let's go this way also. Let's go this way also. If you take this, what it is? 1 plus, so 1, 1 minus 1 plus 1, and 1 minus 1 minus 1. Okay, so that's one more direction. So 1 minus 1 plus 1, 1 uh, minus 1 minus 1. So which is 2, which is 1. And similarly for this also. Now what I'm trying to say is, if you closely see, this is giving 3. Okay, so this is better way to write it. So let me handle everything. Then we will write a logic to calculate everything. So this is giving 3. This is definitely giving 2 because 1 plus 1 plus minus 1. And this is 1 minus 1 plus 1, so which is 2. And 1 minus 1 minus 1, which is minus 1. And this is minus 1 plus 1 plus 1, so which is plus 1. And minus 1 plus 1 minus 1, so which is minus 1. And minus 1 minus 1 plus 1, so which is 1, and which is minus 3. So if you closely see, we found two things where sum equal to, I think, only two possibilities. 1 1 minus 1 1 minus 1 minus 1 1 1. Yeah, it is 1. Correct. Then what else other? Plus 1 minus 1, which is minus 1. Now if I start from minus 1 plus 1 plus 1, so which is 1. Uh, okay. What else? Minus 1 plus 1 plus 1. So there are no possibilities with target 2. No, right? So let's take target 1. There is a possibility. This will also 1, right? This will also 1. Second, 1, 1 plus 1 plus minus 1, which is 1. This is also 1. Minus 1 minus 1 plus 1 minus 1. So minus 1 plus 1 minus 1. Minus 1, 1, 1. Okay. So let's take target 1 only. So if you closely see, we found total how many ones? 1, 1, 1. Total 3 ones. That's it, right? These are only the three possibilities, right? Correct, na? So now we have find three ones. How do you return the result, right? So if you see, when you reach the target and it is it is returning, definitely if when you reach the n and the your target is not equal to, the sum is not equal to target, then you will return 0. Otherwise you will return 1. So I'll just, this will return 0, this will return 1. The sum of these two is equal to 1. Then here also, here target equal to 1, right? So this will return 1, this will return 0. The sum of these two is 1. And the sum of these two values will be 2. So this will return 2 here. Now, if you come down here, target equal run, right, 1, right? So this will return 1, and here target is minus 1. This will return 0. The sum of is 1. And when you come here, target or both are not equal to 1. So both will return 0. The sum of these two is 0. And sum of these 1 plus 0 equal to 1. So that the total sum 2 plus 1, which is equal to 3. So that we need to return 3. Clear na? Clear na, buddy? So, yeah, so to write a recursive logic, right, but first be clear about the flow, recursion rule. So now what is our job? Private int count ways, integer index, integer array nums, and integer target, and integer sum also. Okay. Can you manipulate on? So better you handle with sum so that an integer flag is boolean. Boolean is plus. Okay, so symbol. Okay, so symbol. You can say symbol. Okay, better. No, let's take it as a symbol. Whatever symbol you pass, so that things follows our diagram. Okay. So now one thing for sure, if your index is equal to nums dot length, then what is your job? So you can return if sum is equal target, you can return 1, otherwise you will return 0. This is one perfect. So you don't do other thing, man, because we should include all the elements, right? So definitely it's not mad, it's not include exclude on index, it include exclude on symbol. Index will always be included. Correct? Correct, buddy. So now what is your possibility now? Do you really need this? I don't think you need this symbol. So one is for plus, right? So one is for plus, one is for minus. See, I am writing for both. I am writing for both. So carefully understand. So count ways. Both of the cases you will reach to index plus one, and nums target, and one is for plus, right? So sum plus nums of index. One is for minus, right? So whatever possibilities. If you see the recursion tree, right? We took sum of both the elements, right? Sum of both the directions, right? Yes or no, bro? Done, na? Is it not correct? So we'll start from index 0 for a given nums and given target, and sum becomes 0. Correct, na? Right? See how simple it is. But the recursion tree, if you closely see, that's what we did on recursion tree, right? So we took both the directions and we just considered sum of both the directions. Correct? At the last, if it is 1, we'll return, if it is target, we will return 1, otherwise we will return 0. So whenever you get everything, and we'll just consider it. Correct? Correct, na, buddy? So yeah, but getting into this, right? Getting into this is very tough thing. And this plus symbol you need to add, right? Between line number 13, you need to add plus symbol, right? That plus symbol you will not get if you don't draw the diagram. Okay, now what is a funda now? What is a funda now? Now let's move on. Do you find repeated subproblems? Do you find repeated subproblems here? Huh? Based on what you will consider repeated subproblems? Hmm. So here I didn't maintain the sum. I didn't maintain the sum at each level. So let me do that. So here sum was 0, right? Let me take my favorite color. So here sum was 0. Plus 1 means here sum was 1. Correct, na? Buddy, Ajay, Akash. No, earlier I didn't mention the sum, right? So I'm just mentioning the sum so that you can 0, so it becomes 1. Now here the sum becomes 2. Here the sum becomes 0. And here sum becomes 3. Here the sum becomes 1. Here sum becomes 1. Here sum becomes minus 1. Here sum becomes minus 1 and 0 plus 1 minus 1. Here sum becomes minus 1 comma minus 1 minus 2 minus 2 plus 1 which is minus 1 and minus 2 minus 1 which is minus 3, right? So this is what we did, right? Okay, perfect. So now can you tell me, do you see repeated subproblems? Based on what you need to consider repeated subproblems? Alright, this one is result, man. This one is result, okay? So index and sum, right? So one is index, another one is what? Sum, right? Correct, na, buddy? So do you see these problems are repeated? So here it is repeated, right? Now we can, now what is the time complexity for brute force? Brute force time complexity is what? 2 power n, right? So space complexity? Are fast, man. You don't should not think about too much. Now we understand that there is a repeated subproblems, right? So repeated subproblems are this one and this one. So now what is the DP state now for memoization? So memoization. So DP of what is the value? How many DP should include what? Perfect, right? So it means uh, target or what? But target is only one, right? What sum it is? I understand sum. What sum it is? Perfect. So that is sum of all the elements. Correct, na, buddy? Sum of all the elements, na, bro? So here target is smaller. Sum of, if you see our total sum went up to 3, right? So which is sum of all the elements. And it also went up to minus 3 also, right? Correct? But how do you handle minus 3? Minus 2 to plus 3, right? So definitely you need 2n size, correct? 2n size, na, everyone please. We need definitely 2n size because this will need negative direction and positive direction. This will need 2n size. Can you spend some time on it and try to converting it to memorization is very dead easy, but handling on here is little tough because you have minus threes and plus threes. Then how do you do that? Do you handle through? Do you handle to DP array? Do you handle to DP array? If you are able to handle to DP array, how do you handle negative values? Okay, now how do you represent this? Now here dp of dp array size is I comma sum, right? So in this case I equal to 3, sum equal to minus 3. So do you have minus 3 index? Index will always be 0 to, so 0 to n, right? So how do you define this? So one way is you can handle through plus 2n. So you can take when you take minus, whenever you find a minus value, and you will just add the same value. So minus 3 so you will just multiply whenever it is negative, you will just multiply it, then it will become 6 plus 6. So you can store that value into plus 6. There is a mathematical formula. You can somehow figure that out. Negatives you can convert into positives. Okay. So 1, 2, 3 is fine. But when you get minus 1, how do you represent it? So minus 1 should be represented as 4. Minus 2 should be represented as 5. minus 3 should be represented as 6. Okay, so somehow you can do that, but but do you really need to struggle that much? Then what else? Are you are engineers, right? If you are a fresher, I could not have said that, but you are engineers. What if the target is negative? If the target is minus 3? Tell me, man, don't think about the array. Think about some other way. You need to hash it, right, somehow. How do you hash it? It means hashing only now, man, this one. How do you, what is the other way? What is the other way? Release the suspense, we can't bear it, huh? Huh? Array, man. Is it not solving, man? Map of index, comma, map of sum and value, or it means target. Is it not solving? Index means this is index number, sum means your current sum, value, whatever value you get it. Do you really worry about taking DP array and considering all this? So you can represent in the form of map, right? Yes or no? Kalyan, you didn't understand, right? So the problem is, first you need 0. For example, target is 3. 0, you have 3 indexes, 0, 1, 2, 3. Till now we maintain, right? This is our index and this is our target. And each index you will maintain a value, right? Each cell you will maintain a value. Can I represent this as a map? So can I have a map of index? It means index and map of, or you can say map of entry. So it will have only one value. One is int is nothing but this is my current sum and what is the value it is having. Even sum also minus or plus doesn't matter, right? So this is index, this is key, and in the key you will have a value as map dot entry. Per cell you will have only one value, right? Yes or nobody? Per cell how many values you have? Only one value, correct? Ajay, Akash. So if you want to take it more precisely, so you will have a map of index and you will have some variable, some class object, or you can take a pair. It's up to you. Value, how do you want to define? It's up to you. So, cell sum, cell. So you can have sum and you can have value. So take sum. Whatever value you get, if the index equal to n and the value you get which is equal to target, then you return 1. Correct, na man? Correct or not? So, but I would suggest go with map of y. I would not suggest go with map of cell. Why? It should be the valid answer is map of map. Why? That is okay. But single cell, right? If you have multiple, this is correct. This is fine. This is fine. Why it should be map? The second part. But I'm saying one cell, right? So that's a wrong observation. We getting have so for a given row, given column, you will have one cell. But for one row, you have multiple columns, right? Yes or nobody? Arey man, for zeroth row, don't get confused, man. So for zeroth index, the target sum, if you take target sum equal 3, it can be 0 or 1, 2 or 3, right? Or it can be anything. It can be not target sum, array sum, which is equal 10. So it can be up to 10, right? It means index 0 can be representing any one of this sum, right? Yes or no? Arey, what you did, why are you confused? If you closely see, if you closely see here, for index 2, how many sums we have? We got index 2 0 sum, 2 sum, 0 sum, minus 2 sum. So you got many sums, right? Yes or no, buddy? So it means it can be for index 2, for any given index, the sum can be minus sum to plus sum, right? So it means you will have multiple values for a given index. So that's why you will consider, you will go with the map. That's how you will represent. Correct? How do you do it? So how do you represent this? Okay, how do you represent this? So if if you take this index, how do you represent this? Right, don't kill us, please leave us. How do you represent this? So it means, what does it mean? So you have 0 0 some value, 0 1 some value, 0 2 some value, 0 3 some value, and so on, 0 10 some value, right? So it means I will take with a single key, with a single key you have multiple values, right? So you have multiple values. That's correct, right? So I can represent this as map of single key index, and I'll have multiple values. So map of whatever sum you have. This is sum actually. So plus the whatever value I get it. Okay, so I'll just represent that way. Clear na? Because why I consider map here? Again, you come to same thing now. If I don't consider map, what should I do? How can I identify duplicates or problems? If you closely see, here the problem is duplicated, na buddy. So for this problem is duplicated, right? Because index and sum are same. Index and sum are same. So this problem is duplicated. So this problem is duplicated. So how do you identify duplicate? So if I get the index, I can easily find out a sum through hash. So if it through hash, it becomes easy for me. Where I am? For me, through hash, it becomes easy. If there is no hash, right, I need to traverse all other things. So I need to generally, if it is not map of sum of value, then how should I take map of index, comma, list of pairs, right? So list of pairs, because one index is representing multiple columns, right? So multiple columns, I should consider list. If I consider list, I need to traverse everything. So we were into wrong assumption that. So what I'm saying is, per cell you will have only one value, but this cell is belonging to one index can have multiple cells, right? Multiple columns, right? That's why you should either index comma list of some pair object that will have sum and value, or map of sum comma value. So if you go with map, this sum you can find it in constant time. Do you understand what I'm trying to say? That's why you have map, right? Only for sum. We will search by sum so that you will get a value, so that you can easily find. If you closely see, if you solve it already, what you do? So with index 2, with index sum 0, you got value as 1. Okay. Now when you come here, you will see, okay, with index 2 with sum 0, I got already having value, so that I can directly return that 1. So that this will not be solved again. When you are solving this, when you solve this, what is the sum? What is the value you got? 1, right? Result you got. Value means result, na? Yes or no? Yeah, that is what I'm saying, right? So generally, what will happen once you're done with this, so you will have with index 2 value sum 1, you got value sum 0, you got value 1. So this is one pair you got, right? Now when you come here, okay, index 2 is present, sum 0 also present, so that I can directly return this value. So I don't need to solve it, right? Understood, Ajay? Akash, you didn't get it? Then why are you troubling me, yaar? If you get it, you could say that, yeah, I got it, leave it. If you say that, I could have write the code, na? Can I write the logic? Okay, let me do that. Arey, the problem is even if you get it right, let me know. If you don't tell me that, right? So it would be tough for me to if I explain again and again, it's like wasting time, right? So integer, comma, integer, right? Everything is integer. So this is one thing is for sure. This is clear, right? The duplicate subproblems are index sum. That is clear, right, everyone? So what is the time complexity now? What is the time complexity? Yeah, so n into total sum, right? So if you go with memoization, the time complexity, so time complexity n into target sum. And what is the space complexity? N into target sum for DP plus n for stack span, right? So the problem is we are not in class now, and I don't understand. I don't know whether you understand or not unless you speak out. If you already get it, just tell me that. If I'm over explaining, just tell me that we understood. Just stop it so I can stop it. Okay, so yeah, uh-huh. Perfect. So okay, nice. So we will just go with it. So way map. So closely understand. So ways map, or I'll just take it as a map. Otherwise, you will consider it as. So what it is representing? This map of uh, index, then map of value is going to be map of uh, current sum, comma result. Okay, so result means value, whatever result it is, or count ways in your ways, count ways. That's fine, right? So if I say result or value, is it fine, right? Result or count ways or values. You became like a Paramananda Shishyas to me, yaar. Let's go this way. Okay, so now what is our job? So everywhere we will pass map. Everywhere we'll pass map. ఒక్క నిమిషం 1 minute అయిపోయింది. So closely see here. So you will get a counter here. So whatever count you get here, so what you do? So you will take that, you will get map dot put if absent for a given index, new hash map. If it is not present, it will just put it. So what it'll do? So map dot get of index dot get of. So yeah. So closely understand. Uh, Let me do one thing. Map dot get or default of given index. So if the value is if it is already there, it will give that map. Otherwise, we will get a previous map. So map of integer comma integer. This is our sum map, right? Okay, so you see this is sum map. Okay, so this we get for a given index. If it is present, it will give. Otherwise, it will return default value. So sum map dot put off with this given sum. Okay, so this is my sum. With this given sum, I got the counter. This is a counter. then what I should do, I will add this to the main map. Okay, so let's make it as base map or DP. DP is our famous name, so let me make it as DP. Okay, now what should I do? So DP dot put off for this index. So you already calculated the map, so just take that map and add it. Finally, return this counter. Okay, so this is for simple way of assigning. I'm not doing any complex thing, but a little logic. Now, what you should do here, if so, you need to see that if this map, this DP, right? So, if this DP contains key of given index and DP dot get of index. Array, this is simple logic, man. Don't get confused here. If you say you didn't understand this logic, then don't attend from tomorrow. Contains key of sum. Then what is your job? Just return dp dot get of index dot get of sum. Clear, buddy? Clear? Others also clear, right? Where I am here? Where I return? Array, where we return this logic, man? We return this logic in other. Oh, correct only, no? Okay. Okay, done. So let me run it. So don't ask me question. So done, man. So that's how you think. Okay, of course, don't ask me question that we didn't discuss about hashing, then you implemented hashing. As you are engineers, we will. So you can try for DP array, but that is a waste of time, man. So you need to go with math. So it's very tough to do that. Hope you understood. Please practice. What we do is tomorrow we will convert this into tabulation. Okay. This converting this one to tabulation is little challenging. If it is overhead logic, we will ignore. Other one will definitely convert. Okay. Hope you are understanding, right? We are understanding, but we are not doing any practice. Huh? Kalyan Babu, Ajay Babu, Akash Babu. Okay, buddy. See you tomorrow. I'll drop my kid to school. Bye.